Hello viewers, welcome to Add-on. In this question, we are asked to find the decimal equivalent of this two octal number. The number which is given to us are 365.24 with a radix of 8, which means it is an octal number, and 68.4b with a radix of 16. This is a hexadecimal number. So we are asked to convert the decimal equivalent of this octal number and the octal equivalent of this hexadecimal number. Okay, so let us start with the solution. So in order to convert a octal number into decimal number, we need to learn about the concept of positional weights. Now what is a positional weight? Suppose for this number 365.24, we need to first notice where the decimal point is located. Like in this case, the decimal point is located between the 365 and 24. So what do? We just write the positional weight in this manner. On the left hand side of the decimal point for the first number, we will write the positional weight as a power of 0 of radix. This means the radix of octal number is 8, and by a power of 0 we mean on the left hand side of the decimal point the first positional weight will be 8 to the power 0. Okay, and one thing to be noted that the positional weight will increase on the left hand side, and on the right hand side the positional weight will decrease. So for the next number, this 6, the positional weight will be 8 to the power 1, and for the next number 3, the positional weight will be 8 to the power 2. Similarly, if the number was lengthy in size to the left hand side, we will get 8 to the power 3, 8 to the power 4, and likewise. And now for the right hand side of the decimal point, for the first number, as I have said earlier, the positional weight will decrease. So this have a positional weight of, this 2 have a positional weight of 8 to the power minus 1. As I have said earlier, the positional weight will decrease. So here the positional weight of 8 to the power 0, and the left hand side it was gradually increasing, and similarly in the right hand side the positional weight is decreasing. Here we will get 8 to the power minus 1, and for the next number 4, we will get 8 to the power minus 2. And similarly, if the number was lengthy in the right hand side, we will get more 8 to the power minus 8 to the power minus 4, and likewise. So our next step will be multiplying each of this number with their positional weights. That means we need to multiply 8 to the power 2 with 3, 8 to the power 1 with 6, 8 to the power 0 with 5. Similarly, we will do it for the right hand side of the decimal point. And after that, we will add the products together. Like 3 into 8 to the power 2, this will be added with 6 into 8 to the power 1. This will be again added with 5 into 8 to the power 0. We will do it separately for the left hand side and the right hand side. And after doing this process, the number which we will get will be our equivalent decimal number. So let's start with the process. So as I have said earlier, multiply the number which is positional weights. So 3 into 8 to the power 2, then we will have to add the products together. 3 into 8 to the power 2 plus 6 into 8 to the power 1 plus 5 into 8 to the power 0. So this is for the left hand side, and for the right hand side we will get 2 into 8 to the power minus 1 plus 4 into 8 to the power minus 2. So if we done the calculation, we will get here 245, and here we will get 0.3125. So after that we will just combine these two numbers together. So we will get 245.3125. This will be our required decimal number. So it will have a radix of 10. Okay, so our next problem is converting this hexadecimal number into its octal equivalent. Okay, so let's start with the process. So the conversion process will be in two steps. First, we will need to convert this hexadecimal number into decimal, and then we will convert the decimal number into octal. So the conversion process of a hexadecimal into decimal will be just the same like the octal as I have discussed here. Only difference will be here, as the radix of octal number is 8, we are writing 8 to the power 0, 8 to the power minus 1. But in the case of hexadecimal, as the radix is 16, we will write 16 to the power 0, 16 to the power 1, 16 to the power 2, likewise. Okay, so let us start with the conversion process. So 68.4b Here we will get positional weight of 16 to the power 0, here 16 to the power 1, here 16 to the power minus 1, here 16 to the power minus 2. Then we will just multiply it and add them together. 6 into 16 to the power 1 plus 8 into 16 to the power 0. It will give us 104, and then 4 into 16 to the power minus 1 plus b into 16 to the power minus 2. And b signifies that in the hexadecimal number system, from 0 to 9 we represent it as just like decimal 0 1 2 3 4 5 6 7 8 9, and for 10 we represent 10 by a, represent 11 by b. Okay, so here b signifies 11. So if we done the calculation, it will give us somewhat like 29296875. Okay, now the decimal equivalent will be just the combination of these two number, which will be 104.29296875. Okay, so the next process will be converting this integer part and this fractional part into is, we can say, is into octal number system. So for the integer part 104, in order to convert it into its octal number system, we just need to divide this number 104 by 8, which is the radix of the octal number system, and we have to keep the track of its remainder. Okay, so if we done the division process, we divide 104 by 8. So here we will get 8 ones are 8, 24. So here we will get 13, I guess. 24, yes, it will have a remainder of 0. Then we will use 8. 8 ones are 8, it will have a remainder of 5. So after that we can divide it further. So if we divide it by 8, we will get here just 0. So we won't continue the division process up to that. Then we will just keep the track of the remainder. This is 1, this is 5, this is 0. So for 104 we will get a equivalent of 150. Okay, and now for the fractional part, we will just multiply it with 8. We will multiply 29296875 into 8, and then the result which we are getting, then we will again multiply it with 8, and so on. Like here in this solution, we are multiplying 0.29296875 into 8. Okay, 29296875 into 8, this will give us 2.34375. And for the sake of the simplicity, we will take it, we will take the 2, then we will multiply 0.3475 into 8. This means when we are multiplying 0.29296875 into 8, we are ignoring the integer part, which is this part 2. We are only taking the fractional part. We are again multiplying the fractional part with 8, which will give us 2.75. We are again ignoring the integer part and we will take the fractional part. So again we will multiply 0.75 into 8. So here we can see that there is no fractional part. So we will take only 6 here. So here we are taking 2, here we are taking 2, and here we are taking 6. So our equivalent will be, this fractional part will give us the equivalent of 226. So this is our required octal number from this hexadecimal number. Okay, thank you.